right, Algebra 2, here is your video for 6.4, rational exponents. Okay, rational just simply means that you have a fraction, so fractional. Okay, fractional exponents. Okay, so if we were to use our calculator here to compute these questions that are on your notes, you have 9 to the 1 over 2. Notice that I have to have the fraction, the exponent, that is a fraction in parentheses. So 9 to the 1/2 is 3, 16 to the 1/2 is 4, 49 to the 1/2 is 7. So what does it look like? What does it look like 1/2 exponent will do? All right, it's going to be a square root. Okay, so when you have x to the 1/2, that is the square root of x. And note you need parentheses around the exponent for the calculator to do its work and give you the right result. What about 8 to the parentheses 1 over 3? Well, we get 2. What about 64 to the 1 over 3? Well, we get 4. And 125 to the 1 over 3? Well, we get 5. So what do we think happens here? 2, we got 4, and we got 5. So what are we thinking happens here? The 1/3 is going to do a cube root. Okay, so x to the 1/3 is equal to the cube root of x. Okay, and so it's, a square root hasn't understood 2 here. So this denominator here is matching this index. This denominator is matching this index. Okay, so what do we think might happen when we have 125 to the 2 over 3? Okay, well this is going to be the root. So this is going to be the cubed root of 125, and this is going to be a power. 125 squared. So the denominator, we're going to formalize this in this box. The denominator is the index, and the numerator is the power. So I take the cube root of 125, which is 5, and 5 squared is 25. Okay, and so you can see that on the calculator. If I did 125 to the 2 over 3, you're going to get 25. So it's that cube root of 125, which is 5 squared, 25. You could square it first. You could do 125 squared first. You could do 125 squared and get the cubed root of 15,625, and then turn around and take the cubed root of that. Okay, and get your answer that way also, but it's just much easier to take the cubed root first. The order of operations don't matter. You can do this first because you have a smaller number to square. We don't want to be dealing with this 15,625. Anyway, 2 options for you. All right, so to formalize this, if you have a to the 1 over n, that is the nth root of a. And here, this is the nth root of a to the n. That's when you have a fractional, a rational exponent. All right, and these are actually the same thing. This power here, this is the power, that just happens to be 1. Okay, so again, this is the numerator, and this is the denominator. Okay, in the fraction, if you look over here, this is the power, and this is the index, which is the root type. All right, so let's do some more problems here. Organized. The 4th root of 625. Okay, so 4th root of 625 is going to be 5. 5 times 5 times 5 times 5. 25 times 25, that is 625. So the fourth root of 5 to the fourth is just 5. Okay? Let me grab my glasses so I can see. These numbers are awfully small. So this is the square root of 16 cubed. The square root of 16 cubed. So I'm going to take the square root of the 16, which is 4, okay? And then I'm just going to do 4 cubed, which is 4 times 4 times 4, which is 64. That's the right answer. All right. Over here, we have a negative exponent in the problem. So that's going to send the 25 down to the denominator. So this is 1 over 25 to the 1/2. And we'll just go up here. So that is 1 over square root of 25. So that is 1 over 5. 1 over 5. And then our last one, this is a negative exponent. So I can apply it to both of these, you know, kind of a power to power feel. And when I apply the negative to the 4 and the negative to the 9, they're just going to reciprocate. So this would be 9 over 4 to the 3/2. So you could do it that way instead of, you know, writing it on both of them. You could do it like that, or you could just go ahead and reciprocate the 4 and the 9 to 9 over 4, and then the negative sign goes away because they've moved, and they'll still get that power on them. So this is the square root of 9 quantity cubed, and this is the square root of 4 quantity cubed. Okay, so this 2 in the denominator said to take the square root, so that's 3, and cube it. Square root of 4, which is 2, and cube it. So over here we're going to get the square root of 9, which is 3, and then 3 cubed. The square root of 4, which is 2, and then 2 cubed. So our final answer here is 27 over 8. Okay, some problems here. All right, so be careful when you have negative 5 times negative 5 times negative 5, all to a power. Keep the base as is. Keep the base as negative 5. And then we have 1 over 3 plus 1 over 3 plus 1 over 3. When you have the same base, you leave it alone and you add your exponents. So negative 5, 1 over 3 plus 1 over 3 plus 1 over 3 is 3 over 3. So this is just equals, this is just negative 5 to the first power, which is just negative 5. All right, so this is just, you know, a square root of 7 and the square root of 28. Those can all go under the same root, under the same square root. I'm going to break 28 up into 7 and 4. Okay, I can take a square root of a part of 28. I can take a square root of that 4 piece. And then I'm left with 7, which is nice because 7 times 7 is 49. And so that's 7, and that's 2. Those get multiplied, so this is 14. All right, and then number 7, these are all cubed roots. So let's just put these all under a cubed root, and let's just factor out 12. And just see if I can get groups of 3 here. So 12 is 4 times 3, which is 2 times 2 times 3. Okay, so that's 12. All right, if you were just to do a little factor tree, 4 times 3, 2, 2, 3. Okay, 45 is going to be 9 times 5, which is 3 times 3 times 5. Again, just with a factor, little factor tree like here. 12, 4 times 3, 2, 2, 3. So if you had 45, you would get 9, 5, 3, 3, 5. And then 50 would be 5 times 10, which would be 5 times 5 times 2. All under that cube root. So 50 here, just 5 times 10, and then 5 times 2. So 5 times 5 times 2. All right, so this is the cubed root of, let's count them up. I got 1, 2, 3 2s. So that's 8, or you could just say 2 cubed. Got 1, 2, 3 3s, so 3 cubed, and 5 cubed. All right. And so this is great because a cubed root will knock out a cube. 3, and 3 will negate, and you'll just get that base of 2. So this is like the cube root of 8, which is just 2, the cube root of 27, which is just 3, and the cube root of 125, which is just 5. So when all is said and done, this is just 2 times 3 times 5, which is 30. Okay, in your homework, you're going to have to do some conversions. That's the next step here. I know I'm going fast, but you can pause the video, so I always go a little faster on the videos than maybe in class. But where am I? So here, so this is just converting to radical form. This is just the cube root of x to the 4. Okay, and it didn't say to simplify, so I'm not going to, but if you were to simplify, you'd say x cube root of x. But we're just working on conversions here, so I'm going to leave it at that. All right, this is the 7th root of t squared. All right, and then the next one, we'll leave that. The next one is just a negative 1.6, so this is going to be 1 over a to the 1.6, and I want to put that as a fraction so I can put it in radical. So what is 1.6 as a fraction? Well, it's 1.6 over 1. All right, and if I were to multiply that by 10 over 10, I'd get 16 over 10. And if I were to reduce that, I'd get 8 over 5. So this is 1 over a, 8 over 5, or 1 over the 5th root of a to the 8th. Okay? And then going the other direction in exponential form, this is just x to the power over root. Remember, that's a square root right there, so x to the 3/2. This is just m to the 1 over 3. And right here, this is just 2y squared to the 1/3, or 2 to the 1/3 y to the 2/3. Either one of those would be fine. Okay, and then the last 3 here, some simplification. So this is just a big cubed root because it's to the 1/3, so we're just going to take the cube root of all of this. All right, so the cube root of 27 is 3. 3 goes into 6 twice. Cube root of 64 is 4. And 3 goes into 4 once with 1 left over. Okay, so there's that. That's all the cubed root pieces. And then I want to rationalize the denominator. So I want to get this root 3 out of there in the denominator. So I need to bulk up this denominator so that the cubed root has 3 y's underneath it, not just 1. So I need to supplement with 2 more here. And I'll do that over itself, so I'm just multiplying by 1. So this numerator is 3x squared cubed root of y squared. This is 4y, and then this cubed root of y times this cubed root of y squared will all shake out to be the cubed root of 1, 2, 3y. So the cubed root will negate the y cubed, and it will just reveal the base of y. So y times y is y squared. All right. This one, let's do power to power. X to the negative 2 over 3. 2 times negative 1/3 is negative 2 over 3. Y squared. X to the 2/3 times 2. Power to power, so I'm just doing this 2/3 times 2. That's 4 over 3. So down here I have x to the 4 over 3, and then this is, 2 times negative 1/2. That's just going to be negative 1. All right, so let's make things comfortable here. I'm going to have y squared up top, and y to the negative 1 will go up as y to the positive 1. We've got x to the 4/3 in the denominator, and then x to the 2 over 3 will come down. So a total of y cubed up top, and x to the 4/3 plus 2/3 is x to the 6 over 3. So that's y cubed over x squared. Y cubed over x squared when all is said and done there. All right, last one. First thing I would do is, if you can reduce, I would. 3 goes into 12 4 times, and 3 goes into 75 25 times. Okay, and then so that's going to be easier because I'm going to do the square root of 4x to the 8 over 25y to the 10th. So the square root of 4 is 2. Square root of 25 is 5. 2 goes into 8 4 times. 2 goes into 10 5 times. There you go. All right, so that is 6.4, you guys. And we will see you next time in class. Thanks.